Hello, you're with Bahati Abdul Karim, and I'm taking you through A-level applied mathematics. This time round, we're going to look at flowcharts. This part is suitable for Senior 5 and Senior 6. This is our course outline. We're going to look at the introduction. Next will be a dry run, then constructing flowcharts, and lastly, we shall look at Newton-Raphson's method with flowcharts. Let's look at the introduction first. A flowchart is a diagram comprising of systematic steps followed in order to solve a problem. Here, you should not worry about a flowchart. These are like the steps that you go through to solve a problem. For example, after waking up, the first thing you may do is praying. After praying, you may lay your bed. After laying your bed, you may take a bath. After taking a bath, you may comb your hair, maybe put on your clothes, and then pick your materials and then go to class. Here we go through steps to solve a problem. And these are some of the shapes that we use. The first one is used for start. So you can use that oval shape for start. And you can still use the same shape for stopping. Never forget to start and stop your flowchart. If you do that, you lose marks. You can use that shape for start also, and you can still use the same shape for stopping. Then 2, we have operation assignment. Here we use that shape. That statement inside can be read as n becomes n plus 1. Don't read it as n is equal to n plus 1. No. It's n becomes n plus 1. So we are assigning a value to n. Then you can still use this shape for assignment also. N becomes n plus 1. And then you can use this shape for reading initial values. You're reading an initial value. And then you can also use this shape for printing. So you should note these shapes, always use them rightly. And lastly, we have the decision statement. And this one is always in that shape. So you will always put your decision in here, and this is where you decide whether to print or to continue. So here you may ask, for example, do I have all the materials that I need to be in class? Yes. If yes, then go to class. If no, first pick the materials and then continue to class. This is where we put the decision statement. So here we're starting with how to perform a dry run. And a dry run is the method of predicting the outcome of a given flowchart using a table. And here we have our first example, which says, perform a dry run and state the purpose of the flowchart given below. So here we have our flowchart, and as I told you, a flowchart must be initialized. You must start, and then at the end you must stop. Because if you don't do that, it will continue again and again, and that's not how it is supposed to be. Everything has a starting point and a stopping point. Like a computer, when you give it a command, you have to have where to stop. If you don't, the computer will continue again and again. So always, you have to start your flowchart and you have to stop your flowchart. So here, after starting, this flowchart says that we read n equaling to 0 and a as 1. So after reading those initial values, we have n becomes n plus 1. So our n is now n plus 1. So initially, if our n was equaling to 0, now n becomes 0 plus 1, which is a 1. Then next is that a becomes a times n. So our a initially was equaling to 1 at this point. And then at this point it becomes a times n. Our n is 1 and our n is 1 and our a is 1. So we shall have a which is equaling to a n become 1 times 1, which will become a 1. So at this point, our a is still a 1. Then we continue to the next. You should always follow the arrows. The next one is the decision box, which is asking you, is n less or equal to 5? If this is a yes, then you have to follow the arrow. If it is a no, then you have to follow the arrow. But in this case, they are saying that if it is a no, if n is still less or equal to 5, if it is less or equal to 5, then what do? We print the value of a and then we stop. How about if it is a yes? If n is still less than 5, then what do? We go back and increase the value of n, because this arrow comes and up to here. So you go back and add a 1 to your n. So we're going to perform a dry run, and after we state the purpose of the flow chart. So as we said that a dry run is the method of predicting the outcome of a given flow chart using a table, we're going to draw our table here. And in this table, we're going to have n and a. So how do you know which value to put here and which value to put here? The first assignment gives you the first value in the table column. So the first column will have n because n is assigned first. And the second will be a because a is assigned next after n. And then you come and start. After identifying your table columns, you come back to the flowchart and start. So we start from here, and after that we read n as 0. So our n is 0 and our a as 1. Then we follow the arrow. N becomes n plus 1. So our n is 0, then we add there a 1, so it becomes a 1. Then we follow the arrow. It says a becomes a times n. So our a is 1 and our n at this point is 1. So 1 times 1 gives us 1. And then we follow the arrow. The arrow continues to the decision box. Is n less or equal to 5? I think our n is less than 5. So if it is a yes, then we go back and increase the value of n. N becomes n plus 1. Our n is 1. When you add there 1, it becomes a 2. And then we now come to a. A becomes a times n. Our a is 1 times a 2, which becomes a 2. And then we continue to the next. Is n still less or equal to 5? Yes. So we go back, follow the arrow to increase the value of n. So n becomes n plus 1. Our n is 2 plus 1 becomes 3. Then our a becomes a times n. Our a is 2 times 3 becomes a 6. And then we continue. We ask ourselves, is n less or equal to 5? Yes. If it's a yes, we increase n by 1. So it becomes a 4. And 4 times 6, that is a times n, becomes 24. Then we ask ourselves, is n less or equal to 5? Yes. If it is still less, we go increase n to 5. And 5 times 24, we shall have 120. Then we ask ourselves, is n less or equal to 5? Yes. If it is yes, we continue. And then we shall have a 6, because we are adding 1 to the value of n that we have. And 120 times 6, we shall have 720. Then we ask ourselves, is n still less or equal to 5? No. So if it is not, what do? We print the value of a. So you print the value of a. You say a is equaling to 720 and you stop. That is it. So we have performed a dry run. The next thing here is to state the purpose of the flow chart. This is where some students get problems from. Some students, they fail to get the relationship between the values in the table. You cannot state the purpose of the flow chart without the dry run. To state the purpose of the flow chart, you must have performed the dry run. You look at the relationships of the values in your dry run, and then you can tell which relationship. For example, the relationship can be in form of powers. For example, you may find that to get A, you're powering n values. They can be mean, they can be sum, they can be multiples, they can be powers. So when you check the relationship here, you realize that these are factorials. Because if I have n factorial, I will get A. For example, 0 factorial gives me 1. 1 factorial gives me 1. 2 factorial gives me 2. 3 factorial gives me 6. 4 factorial gives me 24. 5 factorial gives me 120. And 6 factorial gives me 720. So here, this is how we can state the purpose of the flow chart. The purpose of the flow chart is to compute and print 6 factorial. As you can see, 720 is 6 factorial, and it is what we printed only. If we were printing all these values, then we would say the purpose of the flowchart is to compute and print the factorials of numbers from 0 up to 6. That means if our print was here, if our print statement was here, then we would be printing all these. But since our print statement is here, then we are printing only 6 factorial. And then the relationship between A and n is that A is equal to n factorial. You can see these things properly. Let's look at our next question. Example 2 says, study the flowchart below and perform a dry run and state the purpose of the flowchart. It starts with the value of s as 0, the value of n as 1, and then s becomes s plus 1, and then is n equaling to 15? If it's a yes, then you print the value of s, and then you stop. If it is a no, you go back and increase the value of n by 2, and then you get another value of s. So this is the flowchart. So we are going to follow these arrows, and then we draw our dry run. As we said, a dry run will always be in table form. So let me draw the table. This is our table, and you will realize that for assignment, we are assigning n first, then we assign s. So n will be the first in the table and s will be the last. Then our initial value of n is 1, and then our next value of s will be s plus n. Since our s is 0 and our n is 1, so s, which is 0 plus 1, will give us a 1. Then we ask ourselves, is n equaling to 15? If it is a yes, then we can print s and stop. But I think n is not yet equal to 15. So what do? We add n plus 2. So we go to this side. So n becomes n plus 2. So when we add 2 to 1, we will get 3. And then s will become s plus n. S is 1 and n is 3, so 1 plus 3 will get 4. Then we ask ourselves, is it equaling to 15? No. If it is a no, we add a 2 to n. Our value of n is 3. When you add there 2, you will get 5. And then your s will become s plus n. Our s is 4 plus n, which is 5. You will get 9. And then you continue and ask yourself, is n equaling to 15? No. So what do? You add a 2, it becomes 7. And then s becomes 7 plus 9, which gives you a 16. And then you ask yourself, is n equaling to 15? No. What do? You add a 2, so it becomes a 9. So 9 plus 16, you'll get 25. And then you continue and ask yourself, is n equaling to 15? No. What do? You add a 2, it becomes 11. 11 plus 25. What do you get? You'll get 36. And then you ask yourself, is n equaling to 15? No. What do? You go here and add a 2, it becomes 13. And then s will become s plus n. Our s is 36 plus 13. You will get 49. And then you continue asking yourself, is n equaling to 15? No. You continue, add 2 to your value of n. So it becomes 15. And then 15, you will realize that s becomes s plus n, which will be 15 plus 49, which is 64. You ask yourself, is n equaling to 15? Yes. What do? You print s. And printing s, we are printing this value, which is 64. So that means s is equaling to 64. We are printing s after n is equaling to 15. And the purpose of the flowchart is to compute and print the 8th square number, because we printed only the 8th. If we had printed all of them, then we would say the purpose of the flowchart is to compute and print the first 8 square numbers. But here we printed only the last one, because we printed after n is equaling to 15. That's when we printed s. So our next question says, study the flowchart below and perform a dry run and state the purpose of the flowchart. So here is our flowchart, which reads R first and then C as 0. Then assigns C to become C plus 1, then R to become 2R. Then in the decision box, is C equaling to 8? If it's a yes, you print C and R and then you stop. If it's a no, you go and increment C by 1. So we are going to perform a dry run, and then after that we can state the purpose of the flow chart. So here, as I told you, you will always know what to put first here by looking at the assignments. So when you look at the assignments here, C was assigned first and then R last. So our C will be the first and then our R will be the next. So our first C is 0 and our first R is a 1. And then C will become C plus 1, which will be a 1. And R will become 2R. 2 times 1, we will get a 2. And then we ask ourselves, is C equaling to 8? No. If it's a no, we go back and increase C by 1, so it becomes a 2. And then R becomes 2R. 2 times 2, we will get a 4. And then we ask ourselves, is C already equaling to 8? No. What do? We go and increase C, it becomes a 3. And then, after becoming a 3, R will be 2 times 4, which is 8. And then, we ask ourselves, is C equaling to 8? No. So, we go increase C by 1, it becomes a 4, and R becomes 16. We go ask ourselves, C, is it equaling to 8? No. We increase it by 1. We go, this becomes 32. We continue the process until we reach C is equaling to 8. And for 128 times 2, we're going to get 256. So finally, we have C equaling to 8. So if C is equaling to 8, we print C and R. Our C is equaling to 8 and our R is equaling to 256. So that is the first part. We have performed the dry run, and finally we have printed C and R when C is 8 and R as 256, and we have stopped. Then the purpose of the flowchart is to compute and print 2 to power 8. You realize that when C was 8, our R was 256, and 2 to power 8 will give you 256. So that is the purpose of the flow chart. So for the dry run, let's stop here, and in the next video, we're going to look at how we can construct flowcharts. Please like the video if it's good, and comment in the comment box if there is anything you would want from us. And then subscribe to our channel if you want an update for every video that we upload. Thank you for watching. May God bless you.